Well, hi, pre-calculus students. It has been, seems to me, like a long time since I saw you, and I hope you've recovered from my last test. I haven't graded it yet, but I'll get to that. We're moving on to chapter 7. I wanted to tell you I miss you all. It's very strange now with this distance learning. We are going to institute some way for you to get in touch with me through a discussion on my LLA, but I'll talk to you about that in the bulletin announcements and some emails that I'll send to you. I'm not going to take time now to do it. I want you to be able to get started in the homework. If you haven't done this already, it's a review of Algebra 2. This is actually moving us into matrix math, and we're going to use matrices to solve multiple equations, and that's the exciting part about it. You'll be able to use your calculator more freely then and actually have the calculator do most of the really heavy work. Right now today I just want to talk about the first part of the assignment that involves the substitution method and the elimination method for solving systems of two equations. So I'm just going to give you some examples right out of the textbook. Your homework is from some of the problems like this. I'm going to pick one. This is 2x minus 3y equals 0. No, I'm sorry, equals minus 23. And then down here I have x plus y equals 0. And so I'm going to do the substitution method, which seems the easiest to do here. Substitution, I'm going to leave the y where it is and subtract the x. So I now have y equals negative x, and that value I'm going to stick in right up here where the y is. And so I'm going to have 2x minus 3 times a negative x. Well, you can see right there that makes that positive. So we've got 2x plus 3x, which is going to total 5x's, and that's supposed to be equal to minus 23. Well, dividing through by 5, you end up with minus 23 over 5. So I'm going to use that value then back up here to substitute and find the actual value numerically of y. So I think this is the easiest equation to work with. So I'm going to put in minus 23 fifths for the x. 23, there we go. Plus a y equals 0. Well, can you guess what y is there? Pretty easy. Y equals the positive here, and that's why they add up to be 0. 23 fifths. So it's a very simple example of the first section of your assignment. Not going to strain, I don't think, to do that. I just want to warn you, there are some where there is no solution. Your answer will not make sense. The x will not fit back into the equation correctly. Now I'd like to do an example of an elimination question. And let's see here. This one will work. 2x minus 4y equals 8, and minus x plus 2y is going to equal minus 4, they say. Okay, so you may already have a suspicion about this. That suspicion would be that if I double this, I'm going to have this, and that's going to create this. So let's try that. Now, you recall in elimination, what I'm trying to do is get these signs to be opposite, which you already see. So if I multiply this by 2 to get a minus 2x here, that will happen. And then over here, I'm going to have plus 4y's. And over here gives you a minus 8. So if I draw an addition line here and I add these two equations together, then you see I get 0, 0, and 0. Well, what does that tell you? It tells you simply that there's not two equations here. There's only one equation, and because there's only one equation, there's an infinite number of solutions. I don't have a two-system pair. But the reason I did this is not to show you this, but to show you, remind you of the process. You may have done this. Some people call it the subtraction method. I like the elimination method because I'm trying to eliminate one of the variables. You can call it whatever you want to. Just know that you're modifying one equation so that you end up with the variable having the opposite sign and the same value in the coefficient. So when you add them together, they go to 0, and you just have one variable left then equal to some value at the end. Sounds very simple. They get a little complex as we get further into the chapter. There will be 3 variables, and you'll be working with 3 equations at a minimum, but I'll talk about that when we get there. This is intended to be in 7.1a, a very simple reminder of Algebra 2. So if you spend a long time working at this, you probably have forgotten a lot of Algebra 2, or you may not have ever had your teacher get this far in working with systems of equations. So I'm sorry if you haven't seen this before, but it's actually very simple to do. So I wish you success, and I'll talk to you now in the future about 7.1b as we go on ahead in our assignments here.